I just want to kind of go over some of how CryEngine works, what you need to do to get it, what you need to do to build with it and distribute it. So we'll go ahead and start with getting the actual software. So normally you can just get it from the CryDev website, which the URL is right there. CryEngine isn't an installed file; it's just a compressed archive. Just unzip it to your desktop or wherever, and it expects that your entire folder is your project. It's not like Unity where you have the editor and then you set up separate projects that you build like that. In order to use either the launcher or the sandbox editor, you do need to have a CryDev account, which is free. You can sign up on the crydev.net website. And for licensing, it's free for use for academic or non-commercial purposes. They do have commercial licensing, and their indie plan, as listed on mycryengine.com, states that it's 20% royalties. But whether you want to distribute it for free or use the commercial plan, you have to get in contact with CryDev or with Crytek in order to get the CryDev login system removed, because by default everything is required to use that, whether you're distributing a standalone or not. Then once you do have that downloaded, in the CryEngine folder after it's extracted, all of your game data is in this game folder right here, but by default, all the default data is in these .pack files. They're just .zip files with a different name, and all you have to do is extract them. So right-click, 7-zip is what I use, but you want to do extract here. You don't want to extract them to their own archive. So, for example, animations.pack already has this animations folder. So if you extract to the animations folder, then you're going to have too many levels, and it's going to end up causing problems with the file hierarchy. Then I usually just go ahead and delete the pack files because they're not really necessary after you get the game data in place. Whether you do that or not, it's entirely up to you. But I mean, this contains a load of default materials for you to work with and for you to get an understanding of how CryEngine works with, because coming up, it's got materials and textures for wood, stone, grass, dirt, whatever you need. And most importantly, it's got all of the scripts that they use and all of the entities by default. And then it also includes the Visual Studio solution. The solution is built on Visual Studio 2010.
So for extracting all these pack files, this is in the CryEngine folder that you extract from the zip.
Yes.
Inside the game directory.
Yes.
And then you highlight all the pack files, go to right-click 7-zip, and then extract here.
Yes.
Okay.
If you do extract to // that's extracting them 2 extra folders, and it's going to cause problems.
And it already says it contains a file.
That's fine, because some of the animation files are already extracted by default. I don't know why, but they're the exact same files. I've run a diff on them. There's no difference between them.
Right.
So overriding isn't a problem. And then, so the Visual Studio data and all of your C++ scripts are under the code folder. And then in solutions, and right there is a Visual Studio solution. You can either use this when you're writing C++ code, which we're not going to be doing in this workshop, or it does have a project that includes all of your Lua files. If you are, for example, using a plugin for Visual Studio that adds Lua support, it's got that project in there for your convenience. Personally, I usually use Sublime Text, or you can use Notepad++ or whatever other Lua text editor you have. It really doesn't matter. And then I'm going to go ahead and go over kind of an overview of how scripting works with this. It does use Lua for scripting, which I mean, I'm sure most of you have used at least once. And it has very specific expectations of how you structure your tables. Everything in the Lua scripting engine for this is based on script tables. And there are two primary types that you'll deal with when working with CryEngine. There are entity scripts and game rules. We're going to be focusing on entity scripting here. But game rules kind of focuses on actually modifying, for example, dealing with capture the flags. When the player has captured a flag, a callback is called from the script interface, and you can react to that in the Lua script. Then it also exposes a lot of global functions and variables for you to work with. Specifically, what we're going to be dealing most with in this is going to be the vector math, and all of their functions for vectors. It's the name of the function followed by vector, and case does matter in these. So if you notice on the G vectors, it's a global that contains 4 temporary. By default, there's 0 vectors, but it contains 4 temporary vectors that they prefer to use, and it also contains vectors for up, down, right, and so on for you to work with. It does not, or CryEngine doesn't have a built-in Lua editor, as I mentioned earlier. It is purely based on using Notepad or Notepad++ or whatever else you want to use for that. One really nice thing about this, in contrast to UDK, which requires you to completely recompile and then start up the engine whenever you change an Unreal script file, the Lua files, they don't automatically reload, but in the editor you can go into Tools and Reload Scripts, and it reloads every loaded script with no problem. And that's not the Tools folder, it's a menu in the actual editor interface. All entities in CryEngine are defined with 2 files. The first file is just an XML file with the .ent file extension, and all you have to do for that is you specify a name and then the location of the Lua script, and the second file is the Lua script. The name of the entity file, the name provided in the entity file, the name of your script file, and the name of your script table within that script file all have to be the same. So if we had a script named target, it'd have to be target.ent. The script file would ultimately have to end up being target.lua. The table name would be target, and the name specified in the entity file would be target. Each of these script entity tables contains a subtable for client side reactions, server for server side. So it's kind of built in so you don't have to worry about treating client and server separately, because whenever you play a single player game, even within CryEngine, it's running an internal server for you. And so you do all of your logic necessary data in the server side functions, and things that, for example, showing impulses on the object for maybe a fan breaking on the client side. And so it contains properties that you can modify in the editor, as well as properties that are read just by the editor. For example, for showing an icon on top of your model whenever it's placed, so it's easier to pick out in the scene. Yes?
Can you explain what the difference between client-side functionality and server-side functionality are for those who aren't familiar with that?
The server-side functionality is focused on the actual, anything that actually affects the results of gameplay should be in the server-side functionality. For example, when we do our target and we're calculating the score from the player's shot, it's handled on the server side. So it's saying, hey, I've been hit, I've calculated the score, this is what your score was. If you had that implemented on the client side, you could either A, run into an instance where your player's getting bad information, or B, where your client is trying to override the server. Now, everything that you do in the server side will automatically propagate to the player. So usually you don't have to worry about the specifics of how it handles the network trafficking. It automatically syncs all of your information. Entities, one of the really nice things is it's got a built-in state machine. So you just define states in a table named states as strings, and then what it does is it uses it's a subtable of the server table that contains a table for each of these states that you have, and then you're able to go into those, and it's got callbacks that will automatically be called if they exist. So for example, on state begin, on timer, on update, and so on. And one other nice thing is you don't have to worry about the specifics of saving and loading your game data for these entities. There's a callback on the base entity table, call it on save and on load, and it just passes a table into you. And all you do is add a variable to that table. So for example, if you had a fan that was rotating, and you wanted to store its current speed, you just use save table dot current speed equals whatever. And then on the load table, you just do the opposite. So my curve speed equals load table dot save speed. And all entities have reactions. You don't have to explicitly register for the callbacks, except by defining a function. So if you wanted to react to it being shot, you just implement the onHit function, and it'll automatically be called by the entity system. And one other thing is, if you've ever used CryEngine, or not CryEngine, but UDK, and you've used Kismet, there is a visual scripting system in CryEngine that is very much like Kismet, and it is trivial to implement nodes for the FlowGraph, which is CryEngine's version of Kismet, implementing both inputs and outputs. Yes?
For the callback functions, is there a list somewhere for all the callback functions that are supported?
Unfortunately, that's part of where the documentation is lacking. On CryDev's website, if you go to docs and CryEngine 3 free SDK, it does list a lot of them, but it's not by any means a comprehensive, this is every single one you can react to. Many of the functions that you have available on the entity classes are derived from the C++ versions of those. So a lot of the things like to localize a vector, I had to actually go into the source code and find out where it was implemented and what the function name was, and then call it from Lua. But luckily they are fairly well named, so I didn't have to spend too long hunting for them. And then FlowGraph does have a lot of different nodes available for you. And implementing, for example, a scaleform UI, once you've defined the function that UI has, it automatically adds a FlowGraph node for that as well. One thing I do want to cover on the FlowGraph inputs and outputs, which I'll get into more detail when we start editing our script, you don't just have, for example, hey, this is my output to the next node. You've also got a way of specifying variables for those. For example, if I wanted to output a vector for one of my output functions, then I can specify that as a vector type output, and something that expects a vector input will be able to just work with that right off the bat. So one thing that I really love about CryEngine is that it has a very large amount of tie-in with the C++ system. You are given an absolutely massive code base for what they call game DLL, which is the core of your game engine system. And it is very well laid out, very well structured, and very clean code. Their comments, in some cases, are very many comments and very well documented. And in some cases, there's little documentation, but usually in those cases, it's things such as toVector or vector toString that it's trivial. You don't have to worry about trying to find their documentation for it. A lot of their documentation, like I've said, is kind of lacking online. So digging through the C++ code will give you a lot of insight as to what's implemented where and what you have available to you in the scripting or the entity scripting system. And then FlowGraph, like I was saying before, it is the visual scripting system for it. It's very simple to follow. It's a very clean interface for it. And then to get it in the sandbox editor, which is your core level editor for CryEngine, so it's just a matter of open view pane and then you click FlowGraph, which I'll show you when we get into that part later. Are there any questions so far? Okay. One thing I do want to cover that I didn't have in my PowerPoint on entities is for the visual aspects, so any models that you have on your entities, CryEngine uses a system of sub-objects, and they call it slots. Essentially what happens is you can load any geometry, animations, etc. into one of these slots, and then you can either enable or disable them as you wish throughout it. So one thing that they'll do in a lot of cases, for example for a fan object that they've implemented, is they'll load the main mesh for when the fan is alive and working into the into slot 0, and then they'll load in a destroyed mesh into slot 1, and then they'll disable the rendering on the destroyed mesh. Once it enters the destroyed state, they disable the main mesh and enable the destroyed mesh, and go from there.
So is that sort of like components in Unity?
I believe so. I'm not entirely sure. I haven't messed around too much with Unity or rendering systems. So if you go into the game folder that was in there, that was in the X drive, we don't need to worry about entities or scripts. That's just the, those are the two files that I wrote yesterday while working on this again and across the time, which just has our entity file and the script for it. But we do want to copy the objects file. If you go into that, I've got a folder called Workshop. It's just got a default export because I didn't want to have to cover exporting from Maya to get data into here. And so I've got a texture and a model file for that. So if you copy the Workshop folder into your game objects folder right here, then we can go ahead and get started with the scripting.
We have to copy it where?
If you go into the CryEngine folder and go into game and then objects, and then just paste the Workshop folder right there. Because we're going to be referencing that within our script. Then I'm going to go ahead and use Notepad++ for this. Like I said, you can use any Lua capable editor for scripting, no problems. Now, in the CryEngine folder, you've got two types of binaries. You can either use 64-bit or 32-bit. It's kind of a personal preference. I know that the 64-bit does have some issues running on AMD machines. So on my personal computer, I have to use the 32-bit editor. But every time I've used it on these school computers, the 64-bit has worked just fine. I haven't really noticed any difference between the two. Then this is going to be the first thing that you run into whenever you launch the editor or the actual launcher. Just enter your CryDev account information there, which, like I said before, you can get. You can just click Create Account, and it'll take you to the CryDev website for it.
What folder was that in?
It'll be either bin 32 or bin 64. And so, by default, you're going to be getting an interface like this. If you've gotten the...
Yeah, does anyone other than me have a CryDev account already?
I'm signing up right now.
Yeah, I was about to say, you might want to give people time to sign up, because otherwise they're going to be lost.
And I'll just wait for you to finish up.
Although, when
Yep.
to do sign up, you start new level.
Yes, you can go ahead and start that. If it popped up like mine did without that, you can just go to File New in order to start a new level. And the level names you can only have, or they have to be unique. It's not like Unity where you save it to a different folder. Although you can go into your game folder and modify the location of it later if you want. I'm just going to call mine Workshop. Then using the default values under terrain and all that, it doesn't really matter. We're not focusing too much on using this for level editing just yet. Then once everyone's ready, I'll go ahead and start covering some of the basics on how to navigate the editor and get around before we go into scripting. Alright, so once you're at this interface, CryEngine does like to start you off giving you a beautiful view of their water shader, especially underground. Navigating it is very much like Unity. All you have to do is right-click and drag to orient yourself, and then WASD keys to move around. You can hold Shift it'll increase your camera speed by 10 times. And you can also edit your camera speed down here. It's got defaults as 0.1, 1, and 10. Usually, whenever I'm doing large-scale things, I'll keep on 1, and low-scale things, I'll keep to 0.1. From here, you can hit Control-G, and it'll drop you into the game. And so it's got an in-editor game window, and then you just hit Escape to get out of there. And now, one thing that we do need so that we can begin with this tutorial is to get a terrain set up, so I'll go ahead and cover that real quick. So if you go up to the top and hit the terrain menu, and then edit terrain, this is where you do the majority of your terrain work. If you do have multiple monitors, it can be useful to go ahead and move this out of the way and use these tools in the main interface, which does work. But for this, we're just going to go ahead and get started in here. You can set the radius of the circle in here with no problem. I'm going to set the hardness to 1 and the height to 20. And this is under the flatten tool, not the raise lower. So that should give us just above the water as far as our surface goes.
So set your height to 20.
Yeah. And you definitely usually want to set your hardness to 1 as well for just getting started and testing out. And then it does have a lot of items that are useful for you, so you can set the ocean level, you can remove the ocean, you can turn this into an island, which will just kind of, will smooth out these edges over here. And so from there, we can just go ahead and close that, and our terrain is going to be fine. One other thing we do want to do for physics purposes is if we come into terrain and then texture, this is the default material applied to our terrain. And then materials and the actual texture are treated separately in UDK for the most part, at least for the terrain. And so in order to change the material for this, we can click on this little materials link and it'll open the material editor here. Then we can search for whichever material we want. So I'm going to go ahead and make mine grass. So if you come under the terrain folder to the left, then just find a material that you like. And you don't assign materials to the terrain from the material editor window. Instead, once you've got what you want selected in the material editor, you come back over to the terrain texture layers and hit assign material. That'll assign that material that you selected to that terrain layer.
Okay, you lost me about 30 minutes ago.
Okay.
I just finished drawing the island, and
Okay.
you're like 10 steps ahead.
Okay, so if you go ahead and go into the terrain texture menu, it'll bring up the texture layer system. And the way CryEngine handles texture rendering, or materials for the terrains on here, is different layers that can be added on top of each other and so on. And in order to change the default texture or default material, you can just click on the little orange link right there, and it'll open the material editor. And then here you can either create a new one, import an old one, or duplicate and so on. So what I did was expanded the materials folder right here, went to terrain, and then just selected, in my case, grass 2, or you can select whichever material you want to use. Then you come back to the terrain texture layers once you've got your material selected, and click the Assign Material button over here in the left, and it'll assign that material to your material right here. Then you can go ahead and close your material editor after that, and then you just click Change Layer Texture to change what texture you're actually using for that.
Sorry, where is that?
That is over here to the left, under Layer Texture.
How do you select the?
How do you select what?
Select the.
You just click on it, and then over here, Assign Material. And then go into the Change Layer Texture. Now in here, and this is the main reason that we extracted all of our game data files, because we do want to use their default assets. If you go up one level, should take you to here, and it'll show you all of the textures that it came with. And so you can go into terrain, and it's got this variety here. I'm going to select grass.dds and hit open, and that'll make that our texture layer here. Now this doesn't change what's painted on the terrain yet, so you can go ahead and close that. And then if you come over to the right hand side, to the roll-up bar over here, and this second option, this second tab rather, gives you all of your terrain editing features. So you can set vegetation, you can make holes in the terrain, and you can edit different environment variables. But what we want to do right now is go into the layer painter, and we can paint our current layer onto the texture, or onto the terrain, sorry. For the sake of this, just because it'll be quicker, I'm going to go ahead and drag the radius up to 1,000 so that I can set my entire island with one click. And then it kind of looks low res up high, but once you get down to the ground, you can see the detailed texture a little closer. And once you've got that, your texture is set up, it'll show your footprints and it'll treat the materials properly.
So how do you activate that again?
Control G.
Oh, I died. I fell from too high.
You do have to watch where you spawn from, because it does spawn the player at the camera whenever you do that. And in here, just so that you understand for when we start playing around later, you can scroll to select different weapons and items. Right click for your scope. Standard controls, G will throw a grenade. It looks really pretty. And once you hit escape, it clears all of that back out. And so one of the nice things about the materials in CryEngine is it defines how it reacts to everything. It defines what kinds of decals will be applied whenever it's shot, so you won't have to worry in your gun script about applying a wooden decal to this texture or a stone decal to this one. It'll just handle that in the material itself. And so one thing that you can do in here that if you've used UDK you've probably learned to avoid is you can save with Control S. It is safe to do that. You won't lose anything. You can just file save or Control S and you're good. And now to get to a lot of the other tools such as the material editor or the FlowGraph editor, you can come up here to the view menu and click Open View Pane. And then here it's got all of your different tools. So it's got your vehicle editor, a UI emulator if you're working with scale form UIs. FlowGraph will bring up the actual FlowGraph window, which we'll be getting into a little later. So that's kind of the basics of how to get CryEngine set up and get into working with everything. Before we move into actually scripting an entity, I do kind of want to show you how the entities are used. So if you go back to the first tab on your roll-up bar on the right, placing entities in the world is as simple as clicking the Entity tab down here, and then it's got all of these kind of laid out based on the scripts folder within the script/entities subfolder, which I'll show you later. And so you can add vehicles into it, you can add different particle effects, objects, and in our case we're going to be adding our target into the game. And so all you do, and I do recommend if you come up to here, you can turn off grid snapping. then you can, I'm going to pull out a ceiling fan. So you go into the others folder and fan, and just drag and drop. It'll place it there. Then one useful thing for switching between your transform controls up here, you can either use this to choose transform, rotate, and scale and so on, or you can use the 1 through 4 keys. So 1 will be transform, 2 will be rotate, 3 will be scale, 4 will take you back to your selection. And so you can just freely move those around now. And that fan is usually what most of the docs kind of tell you to start with for learning the scripting. And that's actually what I've learned a lot of what I know from. But you can go ahead and delete that. I just wanted to make sure that you understood how to actually place entities in the world. And so now if everyone's ready, or if anyone has any questions, we can move on to actually getting started with the scripting for it. All right, so you don't have to close the CryEngine editor. You can keep it open. You can close it if you want, but like I said, you can come up to the tools folder or menu, and you can reload geometry, scripts, whatever you're missing and whatever you need. Just reload it there, and you're ready to go. So the first thing that is required for a script entity is an XML file that says, hey, this is the name of this entity, this is where you can find its script, this is where everything's located. And all it is just an XML document with a single tag in it. So if you just open it up with entity, and can everyone see that, or should I make it bigger? Or
Here.
Yeah, that's fine.
It's lazy
There you
small.
go.
And then the two things that we define in here are the name, so name equals, and then in double quotes, we're going to just call ours target. And so that is what we're going to need to name all of our files, and what we're going to need to name our script file. The entities are not split up by subfolders, so when working within a project, you do want to keep your entity names unique. So you do need to think ahead whenever you are working on these projects before you just go naming something and then need to change it all. The second tag that we need to do is we need to specify where it's going to find our script. So that's just going to be script equals. And now all scripts, if you go back to the game folder, all scripts are located under the scripts folder. But one of the important things with these is entity scripts are expected to be in this entity subfolder somewhere. You can have it in a folder under that, whatever you like, but it needs to be in this entities folder. And that is how CryEngine, when you go into that entities creation tab, that's how it knows what folder to put those in. So for example, the fan that I drug out was located under the others category, fan.lua. So for this, I'm just going to create a new folder, workshop, and I'm going to end up creating my script in here. And so whenever you specify where the script is located, you specify it relative to the game directory. So in our case, we're going to be scripts, entities, workshop, target.lua. And then just adding a closing piece to that tag. And that right there is all you ever have to do for the entities XML file. And then you just save this. And now it's important to pay attention when you're saving this, so that you save it to the right folder. Under game, you save these files in the entities folder. Do not save them in the script/entities folder, because then it won't find it. So in here, this is where all of the entity files are stored, and CryEngine automatically goes through, pulls all of those in, and says, hey, these are the entities I have available. And so, since we named it target, it's going to be target.ent. And now we've told CryEngine, hey, we've got an entity called target. You can expect the script to be located here. And so go ahead and create a new file and save that under the workshop folder that we created. So scripts, entities, workshop target.lua. And so this is where we're going to put all of our script data saying, hey, CryEngine, this is what our target does. Do you have a question?
What?
You look like you had a question, Nick. Okay. So once everybody's ready, we can go ahead and get started with this.
So the target.ent that got saved in the scripts folder?
No, the .ent folder is under games/entities right here. The Lua, or the target.lua file, is under scripts, entities, then in my case, workshop, target.lua, or you can save it wherever you want. Whatever you use, it has to match the script tag in the .ent file, and it needs to be under the script/entities folder. Then any subfolder such as workshop right here is what it'll show up as in the editor. So if you switch back over to the editor and tools, reload scripts, click entity, and you should see down here this workshop folder. Now it knows that we've got that target. But we haven't specified anything about that target, so we don't want to drag that in yet. Alternatively, if you end up making changes to those, you can also click the reload down here, and it'll reload all of your entity data. So is everyone ready? All right, so for our target, I've set up, and I've already created the texture for it. It's basically going to be a 3-ring target, offering 5 points in the center, 4 points for the ring outside of that, and then 3 points for the ring outside of that, 1 point if you just hit the board and it's not in the circle. And we're also going to have the target raise and lower whenever it's shot. So it'll drop down whenever you've shot it, it'll display your score on the screen, and then the target will come back up. This is mostly so I can show how the vectors are used, how we handle translating it from world space into object space, and what we go about with that. So the first thing that we have to define for our target script is the target table, which in Lua, if you haven't used it before, is just defined like that. And before we go on, this is going to primarily be our properties area. And so we want to kind of initialize the table, but we don't want to define any of the functions yet. So the standard that I've seen through the CryText scripts is they initialize the client and server tables like that, and then they'll fill in those tables later. So if you go in and you copy that down. Now, the way that you expose any data that you want to the editor, so for example, with the fan that I had in here, it's got all of these entity properties down here, so its health, its speed, and so on, is through the properties table in here. And it is important that all of this be the same case, because Lua is case sensitive, and it can kind of be a pain to deal with whenever you run into that. The one thing that we absolutely have to define in here is going to be the physics properties for this object, which is just another subtable. And in here we're going to specify information, just its mass, density, rigid body information, and so on. And now all of these properties have certain ways that they can interact with the editor to give it a hint as to what type it needs to be. So if you want it specifically to be a Boolean, you'll preface your variable with B. If you want it to be a number, it's N. Then I believe it's got vec3 if you want it to be a vector. If you want it to be a file, for example, the file for the model that we're going to use, you prefix it with file and so on. And then CryEngine also has a nice little syntax as far as comments after it goes that can further tell the editor information. So in our case, we can go ahead and set b rigid body equals 0, because we don't want to use rigid body for this, and we do need to explicitly state this. Rigid body active, rigid body after death. And so the rigid body after death is basically just saying, hey, whenever we've shot it, we want it to become a rigid body. Now the mass and the density I've kind of just kept as the defaults that they've had in other scripts. I haven't had any problems with this anyways. So we're going to set density to -1 and mass to 150. Honestly, I haven't played around too much with the physics system. I don't know what each of the other variables affects as far as that is concerned. But that is where we're going with the physics. And then if you go into the editor, it actually places physics, destruction, any subtables we put in there, it'll place as a separate category in there to kind of, that's another way you can organize. Now for this, we're also going to expose what file we want to use. So we'll just call this file model name. So file model name, and like I said, that file bit will tell the editor, hey, we're looking for, you can load a file whenever the user's editing this. And so the default value we want to give this is under our games. We go into objects, workshop, and our file is target.cgf. CGF is the static geometry file format that CryEngine uses, and it comes with exporters for Maya, XSI, and Max, and there's a CryBlend plugin for those of you who use Blender at all. But CGF is the expected file format. So we'll use objects, workshop, target.cgf as our file name. And then we'll also go ahead and add a property to tell CryEngine what we're going to want as far as how fast we want this to raise and drop. So we'll just call it end move speed, and I'm just going to set it to 5 by default. And then one thing that you can do with comments to give the unit or the CryEngine editor a hint as to what you do is if you just put a single comment like that followed by just one bracket. If you put 2, it's going to be a multi-line Lua bracket. The first number that you enter in here can be the minimum, so we'll just go with 1. Then you can enter a maximum, so we'll say 20 is the maximum. Then you can enter a step value, so you define how the fidelity is of this. And this isn't just if you're using the slider, this is also if you are manually typing it. It will use this as the fidelity of it. So if I use 0.1, I can go from anywhere from 1.0 to 20.0, and I can have like 3.1 and so on. But if I put in 3.14, it's going to take it back down to 3.1. Or if you do it like that, then you can 3.14, but nothing beyond that. So I'm just going to use 1 for the fidelity for this. And then you can set a tooltip for that property in the editor. Speed at which target raises and lowers. And then if you want any comments beyond this, you want to put in another comment tag and then put that in. And so that should be all that we need as far as the actual properties for the object go. Then what we want to do is we can define editor properties, and all of the editor properties and all of the physics, the default physics properties available are documented on the CryEngine website. In our case, we're just going to set an icon for it. So if you set a table like this for editor, and this is stuff that only shows up in the editor. You can have a model that actually loads and shows above the object, which is commonly used for lights, and so on to make it easier to select that object in the editor, but it won't render in the world. So we're just going to do icon equals target.bmp. And CryEngine does have a lot of target or different icon files. I'm not quite sure what folder. I believe they're under the editor folder. So yeah, icons right here, or perhaps not. It's in one of the editor folders. So if you want to search up target.bmp, you can find all of the icons available. And then we want to here. Let me verify with my. I just want to verify this other. Okay, icon on top. That will make sure that it always renders the icon on the top of the object, which isn't to say over the object, but it's on the top of the, like at the highest point of the object's measure, rather than at the origin. And so we can come in here and we can set in any variables that we want on the table that aren't necessarily editor accessible properties. So in our case, we'll just add the raised to determine, so that we can keep track of when it's been raised. Well, actually, no, cancel that. We don't need that because of the state system. But now the final thing that we have to add in here are the entity states. This is just a table that contains strings. So in our case for this, we're going to want a raised state, a lowered state, a raising state, and a lowering state. And those will automatically be called the state functions in the CryEngine editor, or in the server table whenever we get to those. Now, one thing as far as the default, why is this not, okay, it is, it's just not changing the icon. The default table does have some callbacks on it. Mostly these are for interacting with the core engine. But we do want to override some of these. So if we come in function, target, and make sure you use a colon instead of having to pass the self variable, then should be on property change. Yes, on property change, and it doesn't take any arguments into it. This is called anytime one of your properties in the editor has changed, so it refreshes the state. So if I go in and I change the file model, it'll refresh everything. And in here, we're just going to call on reset, which will just completely reset the state of the object. Then we're going to go ahead and start a new function for the actual on reset. And this function is going to be called anytime we switch into the game or anytime we switch out of the game and back to the editor. Because if you define states, it does happen. So for example, you saw the ceiling fan rotating in the editor. That's because the ceiling fan is actually rotating itself manually. It's not based on an animation in the editor. That's kind of what we're going to go with, except we're going to be constraining the angles that it's pointing at. So in on reset, let me just look over. Okay, the first thing that we want to do is load our object model, and this ties into the slot system that I was talking to before. So in order to load static geometry, there are different functions for each type. So if you want to load an animated character, you use the load character function. But in our case, we're going to be using load subobject. So then we use self load subobject. The first argument to this command is what slot you want to enter into it. And in our case, we're just going to use slot 0 because we're not going to need any more. The next one is going to be the file name that we want to use, which we specified with the file model name argument. So we can use self.properties.file model name. And that will actually load our object. Then the second thing that we use is, I believe it's draw slot. Yes. This function, the draw slot function, determines whether or not we're going to draw any given slot. So we want slot 0, and we want to enable it. This will make sure that that target.cgf file is rendered whenever this object's rendered function is called. And usually one thing that they'll do is that they'll use the empty string to determine if file model name is empty before attempting to load it, but we don't need to worry too much about that in here. And the next thing that we need to do, and this is a physics bit, so I'm a little weary on this one, is actually enable physics. And this uses our physics table defined up here and it passes it into the entity common function. And if you don't pass this, even if your model was defined with the proper physics material, you'll pass right through it, you won't be able to shoot it, and so on. So you do, even if it's not a rigid body, you do have to pass these. And I'm not sure entirely what all of these arguments are for. Like I said, I haven't touched the physics system very much at all. And so once we do that, we know, hey, our physics system is going to work fine for this. Okay, and I'll go into this step a little later once we start implementing the raising and lowering. But the next thing we want to do is set the state for the entity. And by default, when we place our object, we're going to want it to be counted as being raised. And so Unity offers a great system for getting and setting the states of an object. All it is self set state or self get state to get the state of the object. Once you do that, it's going to go into the state system to initialize it. Now, as I said earlier, for saving and lowering the entity, or saving and loading, sorry, it uses a table that's passed to the onSave or onLoad functions. So in our case function, target onSave, then you can name the variable whatever you want. Then you can come in here and whatever file data you want saved or loaded, you can pull from here. In our case, we're going to save nMoveSpeed. So then it will just be save table, nMoveSpeed, self.nMoveSpeed. And that's all you have to do for your entity to be properly saved. And it's just the opposite for loading. All right, the next thing that we want to implement is the initialization on both the client and the server. And so here we're going to start using these two tables. In my main script, I just implemented everything as one table for those. But for here, I'm going to go ahead and keep them separate, like most of the scripts that you'll find in the game folder handle it. So we're going to use target.client on init. And so this is going to be the initialization function specifically for the client side. And all we're going to do here is call on reset. So we'll go ahead and check if self.beInitialized. And that's something that's added internally by the Unity or by the CryEngine engine. Then we'll do self on init, or sorry, on reset, and then set be initialized to true. And then we'll do that exact same thing on the server side in this case. Then, as a note, if you haven't played around with Lua before, you don't need the semicolons at the end, but you are allowed to use them. I use them mostly out of habit, and I think a lot of the CryEngine devs do as well. So you will see those a lot, but you aren't necessarily required to use them. So now, before we go on and do anything else with this, we'll go ahead and add our item to our target to the scene. One problem: I'm not an artist, so the texture for this is going to be awful. So if we come in and reload our entities, and then go down to the workshop and drag the target in, although you may need to reload scripts because we did edit that. Drag the target in. And it does not appear to be loading correctly. 1 second. Oh, I'm sorry. There is a third parameter to load sub-object. The CTF format can implement sub-objects within your static geometry, and using the empty string will just load the default one rather than trying to search for a specific. So here we should be able to reload scripts, entity, target. That. Okay, there we go. It's a lot closer than I thought. Then, because, like I said, it was kind of awkward for me trying to figure out how to use the exporter properly. It didn't export the texture for this. So what we're going to do is we're going to assign a separate material from the Unity engine's default set to this, as well as change the texture for it. So if you
How do you get the entity in here?
if you go under the entity, under objects on the first tab here, then into workshop or wherever you've placed
Well, we're
that,
getting that.
huh?
Getting that open.
Then just drag it over and let go.
Not like heading workshop folder. It's just supposed to go in game entities, talk about the entity.
The entity is, then where do you have your script saved?
Scripts, entities.
Okay. Oh, here's the problem. For XML, end it with just a slash for that single tag. And go ahead and go back in there and reload. Alright, gotcha.
Is it supposed to print errors in the console, or is it print somewhere else? So I intentionally put an error in my low file by not doing that. I don't see any errors showing up in the console.
Let me see your script real quick.
Yeah. So I intentionally didn't put an end at the if statement, so I should
Okay.
should cause an error.
Here, go into tools and reload scripts.
Yeah.
It can be a little weird with the console. If you go up to your main window and hit Control G, then hit the tilde key. So it is printing it out there. I don't
Okay.
know why it's not putting it down in the bottom. Usually it does. Oh, there it is. Or not. That's a different. That's an error with their HUD, which is something that's in there by default. I'm not sure why it's not showing the error about that.
Maybe it's because I didn't add it to the level, I guess.
That's possible. But usually it would show syntax errors like that. Scroll up some. Huh, I'm not sure. Because I know for me it was showing a load of syntax errors yesterday when I ended up corrupting my file. Because usually it does show them down in the console there.
Let me try adding it and then see if that changes anything. So it's
I'll click back over in the editor. One problem is if you're if you move your mouse out when you're not, or while you've got game mode open, it will end up messing with the. There's your sky. There you go.
all right. So let's see.
And a lot of times, once you've added something, you do have to reposition it. It hasn't added your entity.
Right click the drivers.
No, left right. Because it added your entity in. So if you look around for it, it should. There. Oh, it's added it right there. Okay. So you should be able to hit 1, which will take you into translate. And where is it? One useful feature is if you see up here, or if you hit Control-Shift-F, you can filter the entities that you see on your screen by their name. So target should let us. So does everybody have the kind of not showing-ish model? go ahead and place it on the ground wherever. And if you hit Control G, you should be able to shoot it and not walk through it. And you'll notice that a lot of these are showing up. It's giving bullet holes, but it's also giving no surface type defined. So we're going to be changing that. And sometimes it will kind of glitch out and it won't unload some objects. So you might have to go back in game and come back out before it works properly.
For your enable physics, do you have the enable physics line?
Where?
In the script?
I'm shooting error messages. That's awesome.
What are you talking? What enable physics?
The --2 enable physics is the comment right above it.
Down here. This is the message for it.
Some ones pass through.
It should be. Take a look at your physics properties in your script table. And is everyone else got the target up and working and they can't walk through it? And no yellow lines showing up down here in the bottom? Or at least not too many yellow lines? Alright, now one of the big problems with this, because of how I exported it, and exporting assets really is not my strong point, we do want to change both the texture and the material on this object. So if you go into View, Open View Pane, and choose the Material Editor, then we can go ahead and find a material that will work for this. And one thing that I love is CryEngine comes with a default wood material that we can use. So if you just type wood into the filter up here,
So
you can see
open view pane, which material?
Material Editor.
Material editor, sorry.
Then over in here, just type wood to search for a wood texture. And one thing that we want to do is we're going to be changing the texture on the material in here. So we're going to want to duplicate one of the materials that has been preformed for us. So we'll go ahead and, I'm going to use this matte wood. I think it works well for this. You can use the polished or the wet versions if you want. But I'm going to go ahead and right click and then duplicate in order to change it. So that'll give us matte wood 1. Then you can right click to rename whatever, and it'll bring up a place for you to save it. So I'm going to call this matte target wood. Save. And then making sure that you have your target entity selected, you can click this first button to assign this target or this texture to that entity. And so it gives it a nice wooden texture. And if you go in game,
Wait, hold on a second. How do you select the entity?
as long as it's clicked. If it's showing the transform tools for it, it's selected.
Okay.
Um,
So then drag it onto the entity, you said?
no, click once you've got both the texture you want and the entity selected, you click this button, and it assigns it. And that gives us a lot of useful stats about that. So for example, if we come in and we start shooting this, it starts giving more wood-like texture to the bullets. Unfortunately, it doesn't do anything for the explosions. We've got an awesome piece of board that doesn't explode. But now what we want to do for this, since it's going to be a target, is we want to apply the target texture that I created. So what we do is in the material editor, we scroll down and over in the bottom right-hand side until we find the texture maps here. You can set specular maps, bump maps, whatever you want. In our case, we're going to be editing the diffuse texture. So click the dots down here to bring up this. And I've got that texture file stored under Game, Objects, Workshop, Texture.tiff. You can use either DDS or TIFF textures. Those are really the only two file formats CryEngine works with, so you can't use a PNG. So just double click that, it'll load it up, and you should have this amazing low resolution, 5 minutes in paint texture. So does everybody have a texture target? Yeah. Okay, and the way we're going to script our entity is going to be so that this inner black ring counts as 5 points, this ring will count as 4, this will be 3, and everything else will be 1. And the way I chose to do it is essentially I get the hit info whenever the object is hit through the script. It passes hit information, including the position. The problem is it passes that position in world space, not object space. So there's a function that it's defined in C++ on the base script entity, so all of your entities will have access to it. A function called toLocal, which will translate it into local coordinates. Now, because the origin of this object is down in the bottom left here and not in the center, I'm going to add a value onto it, and I don't know why the coordinates are the way they are when they're transformed into local, but it's treating this as 0, 0, and this up here is 2, 2. So we're going to add, it treats this as 4, 4. So we're going to add 2, 2 to get to the center, and then just get rid of the y coordinate on the transformed vector, and we'll get to the magnitude of the x and z, and that'll tell us how far we are away from the center, and just give us access to that so that we can calculate our score.
Does it use meters for measurement?
I believe it does.
That's probably why you're getting 2, 2.
Unfortunately, it also wants the file, or whenever you set the units in Maya, it wants it to use the default. It won't let you switch that to meters. So I honestly have no idea what unit of measurement it's using.
Well, really, I'm saying just looking at the size of the character.
It's possible.
So that might be
Because I believe that might be about 4 meters by 4 meters, something around those lines. But now if you go in and you shoot it, I mean, it's still showing the wooden style decals and treating it as wood, including the sound, but it's got a fancy texture on it on both sides. It's also really thin. I wonder of the exporter. And so now what we can go ahead and do is come in and we'll start scripting first the onHit handler, and then we can go in and deal with the states themselves. So if we come into our script, now onHit is passed both to client and to server. So on our client, we don't really have to worry about anything for onHit. I mean, nothing important is going to happen there. But on the server, we need to calculate the score. So we're going to be using function target.server onHit. And it's passed one argument, which is just the hit info. And this hit info is a table that contains, like I said, it's got the shooter ID, it's got the world position that it was shot at, it's got the impulse force, it's got the amount of damage, the type of bullet, the type of gun it was fired from, and just a load of information. And this is one of the things that is well documented on the CryEngine, the CryDev docs. And so in here, the first thing that we want to do is get the vector that it was hit at. And CryEngine, the CryDev workers tend to use the G vectors, temporary vectors, rather than defining a local variable. So we can go ahead and store that into our temp v1. And the way we do that is we can use copy vector. The first argument is the destination, and the second is the source. So we're going to use G vectors and make sure that that V is a capital V. .temp v1, which is a lowercase v, and then hit info.pos. That is the world coordinate at which we have just shot and got our hit info from. And now, in order to create that in a local format, we are going to have to use a local variable. So localized hit equals self toLocal. Now this is a function that is defined. This toLocal is defined in the base script entity class in C++ and exposed. It takes a vector argument and passes a vector return value. So we will take G vectors temp v1. I'm sorry, I messed that up. Go ahead and get rid of the copy vector and pass hitinfo.pos directly. I went through so many iterations of this that and get rid of the local. Then I'm getting a little mixed up on some of these. So that'll set our localized vector. So we've got that stored in the global temporary vector.
Now, is the reason that they're using the global vectors because those are C++ and local variables are Lua?
I believe that's the case. I
Yeah,
haven't found
that would make a lot of sense to me.
I haven't found any verified source as to whether that's true or not. And then because of the origin of the vector, we want to, or of the model we're using for this, we want to go ahead and add 2 meters to both the x and z coordinates. Vectors.temp v1.x, it can just be modified directly, and vectors temp v1.x plus 2.0. Then do that for both x and z. And then we want to,
Do you use standard operators like use plus equals, or is that?
plus equals doesn't exist in Lua, unfortunately. Nor does the increment operator, I believe.
Now, the 2 locals, is that also rotated into the local
Yes.
space? That's
Yes.
awesome.
One of the first things that I did was test that it copied or handled it with rotation as well. And then we want to get rid of the y, so we'll just equals 0, because we don't need the y interfering with the actual measurement from our center. And so now that we've got this is pointing right at the center of our object, or the offset based on the center there. We can get the length of this vector to tell us how far away from center we are. So in our case, it's going to be, going to use the length vector function. And it'll return a scalar value. And then we just put in the vector name, so g vectors temp v1. So that's giving us the distance from the center. And now for determining the score of that, since we've got 3 rings of equal size, or equal radius, we can go ahead and get local ring radius. And we can just take the total width of the object, which is, or is it the total width of our vector from the center, which will be 2, or of our object, which is 2 meters. And then we just divide it by 3 because that's the number of concentric rings we have. And so that's going to tell us how far away from the center we are, and this will tell us how far each scoring distance is. So then we can just come in, it can be, I mean, this isn't in any way optimized, but if distance from the center is less than ring radius, then so you can create a score variable there. So what we're doing here is essentially saying if the distance from the center is less than that 1 radius, then we've hit somewhere in this black, regardless of where it is. If it's less than 2 times the radius, it's in this one. 3 times the radius, otherwise we've hit somewhere, but it's not actually in the circle. So we're just going to give the user a score of 1. And since we don't have any UI tie-ins just this moment, we can go ahead and output the score to the console. So we'll just use the log with a capital L, and then we'll just say score. And Lua string concatenation is ... not plus, otherwise it'll give you issues. So once you've set that, you can come into here and reload your scripts. Always make sure you reload your scripts at that point. And sometimes you may have to click the object again to get it to pop back up. But now, once we shoot, right, type to local. Oh, I'm sorry. To local does take the slot that you want it to be localized to. So it should be 0 hit info.pos. Reload script. And why is it?
Everything's a one.
Exactly the same.
You're taking the length of.
Oh, I'm sorry.
Not the,
Yeah, for Z it should be -2. Are these both? No. Okay. Tools, reload. There we go. So if you notice, I mean, just across the line, it changes between 1 and 3.
how do you get that to reappear?
Sometimes you have to drag it again to get
Yeah.
the on property changed. So you just click it and,
Hold on. Or, oh, that's there somewhere. There we are.
okay. So then I'm going to go ahead and quickly do the, or get into the state system for this. All of these states for an entity are handled on the server side, so you want them in the server table. So basically, we'll always be wanting to handle at least on begin state as a callback for each individual state. And so what we'll be doing is function target.server. And then the state name. So we'll have, we've got raised, lowered, raising, and lowering. Raised equals, because we're going to be creating a table for this raised function, or this raised state. And here's where you put in all of your callbacks for that specific state. So in our case, on begin state equals function. And once we're raised, all we're going to do here is go ahead and log that we're in the raised state. Because, and this is just to show you how the state system works and when it changes, because we don't actually need to do any logic while we're in the raised state. And so we don't have to add on end state or any of that in here for this one. We'll do the same thing for target.server.lowered. And most of our state logic is going to occur inside the raising and lowering functions. So now one thing that we can do to change our game logic up here under on hit, we only want the player's shots to count when the target is up. We don't want it to count if the player's shooting it while it's going down or up. So we can add an if statement in here to kill this function. If self get state is not equal to raised. And remember, not equals for some reason in Lua is that and not an exclamation point. And so we can just do that, which if it's not in the raised state, it will end this function. And so now what we can go ahead and do, we're going to go ahead and implement the raising and lowering. And the first thing that we want to do, if we come back up to on reset, we need to store the current value of the of rotation. So if we come up to our target table and add a variable for initial angle, then we can go ahead and use that for storing where we're at when we start. And for this object, we want to use the x-axis as our angle of rotation so that it falls back flatly and comes back up, which is the main reason I put that origin right there for this object. So we come in here, and once again, we're going to be using with the working with the global vectors. And I just want to check the function. Get angles. Okay. So the first thing we're going to do is copy the current angles for this entity into that global vector. So get angles, vectors temp v1. That makes temp v1 now contains all of our angles, which if we've just placed it and haven't actually rotated this, should be at 0. Otherwise, it'll be whatever you set it to. And then self.initial angle g vectors temp v1.x. And it does store all angles as radians, not in degrees. It does give a global for converting between the two, though. And so that's... And now, when we come down to the bottom and add in our raising and lowering methods, we're going to check against that initial angle to get that worked out. So if we come in target server.raising on begin state function, just like we did before. Now, what we want to do for the raising is we want to set a timer that'll go off every 25 milliseconds, which will be it'll give us a static way since we are updating the actual rigid body for this mesh. We don't want to do a regular on update. So we're going to trigger a timer. So we do, I want to say it's set timer. Yes. Okay, so self set timer. The first argument is the timer ID, which in this case you can safely just set to 0. The second argument is the amount of time in milliseconds to call. And then the second callback that we want to add is on timer, so it'll react whenever that's called. And I believe the arguments are timer and then milliseconds. On timer. Okay, self. Oh, right, I'm sorry. On all of these, you do want to add self as an argument since we're not calling them, or since we're defining them as we are. So it'll be self, timer ID, milliseconds. That. Oh, I've been messing up my scripts badly here. I'm too used to brackets. Lua continuously messes me up. And so what we want to do here is first we'll go ahead and determine how much we're rotating by, and then we're going to go ahead and determine if we've rotated as far as we need to or not. Because we're going to, in raising, we're going back to the initial angle. We want to come in here and let's see, okay, 15708. So once again, we'll get our current angles. So self get angles, g vectors temp v1. And then at the end of this, we'll be setting another timer so that the on timer gets called again. And so the first thing we want to do is figure out how much we're going to be rotating by. So we'll go ahead and g vectors temp v1 equals g vectors dot x v1 dot x plus, and then in my case I was treating the initial angle, or not the initial angle, but the movement speed as being in degrees. And so what I did here is just take self dot move, or properties dot move speed, correct? And move speed times g. Is it on the? No, it's just. Okay. So here it's just adding that in degrees. So this is a global exposed by the C++ code for the ratio between degrees and radians. And then here we're going to check if g vector, or if the x modified with that is going to be higher than or lower than lowering. Oh, it's going to be minus. I'm sorry, minus for the raising. Then if it's lower than 0 in this case,
What's after that G?
do what?
It says times G underscore and then.
Oh, I'm sorry. Deg 2 rad, or degrees to radians. So in this case, we're going to want to check if we're less than initial angle. Then we're going to go ahead and set that to the initial angle. And as a note, get angles returns your rotation in world coordinates. So if you've got a sub-object on this and you're doing that, then you would have to translate it. But in our case, since our world angles are object angles or at the same time, it's not too big of a deal. And then we go ahead and use self-set angles and pass in that vector. And this will probably have to be less than or equal to. Though it doesn't really matter, I guess, since we're just setting it equal anyway. Not really.
Now, do you know if it supports Quaternions? Because roll angles are kind of clunky.
That I'm not entirely sure of. I haven't seen, because I know in their math documentation on the CryEngine docs site, it is all listed as vector functions, not as quaternions. I'm not sure if they end up internally turning the vectors into matrices or if they turn them into quaternions. I have no idea. And so that's going to go ahead and while we're raising, it's going to raise us up to the top. And now in here, if we have reached our top angle, we want to set our state to raised. So self set state, or I'm sorry, go to state, raised. And then in our lowering, we're essentially going to do the opposite of that. And we're going to, instead of doing subtracting here, we're going to add the angles. And so target, server, lowering. And then in this case, I'm going to go ahead and take the initial angle plus 1.5708, which is 90 times degrees to radians. That's the exact value that CryEngine uses. So then and remember that initial angle is stored in radians as well.
Is there a global for pi?
Yes, I believe it is G pi. So on CryDev.net, you just go to docs, CryEngine 3 free SDK. 5 is mostly related to scripting, whereas 4 is talking about the C++ side. So common Lua functions and math. Okay, so it's just G pi, and then you've got pi squared, or half pi and double pi, as well as the radians to degrees and degrees to radians. As well as these are your different zero vectors, as well as the up, down, and so on. So then, And when it does call go to state, it does finish going through this. However, the set timer function here will actually, its callback will end up being called on our lowered or raised state. But since they don't have an on timer, we don't have to worry about that. But if you did have that and you were worried about that running again, you could always clear the timer out if you had that chance. Or just return up here and add your angle of rotation there. And so now we've programmed all of our states. And by default, because of up here, it's going to just be staying in the raised state. So if we reload scripts, it should output raised down here. So we know it's in the raised state because of that log output. And that log output also outputs to the console log right there. And so what we can do is we can go in our shooting up here, and the last thing that we can do is we can move to the lowering state, and it will start lowering our target. So self go to state lowering at the end of our on hit function. And so when we reload scripts up here, and initial angles. Oh, I know what I did wrong. I forgot the self for the initial angles. And so there, whenever we hit lowered, it just drops. And that is a little bit fast, so like I said, if you come over into here, the entity properties at the right, everything that you've defined, including the model name and the speed, can be edited right here. So if I change it back to 1, it drops a lot slower. And I can run and jump on it. And now for raising that back up, we're going to go ahead and use FlowGraph so that I can show you how the FlowGraph integration works. So if you come in here, adding FlowGraph nodes is simple for adding your entities. All you have to do is, I believe it's the flow events. I just want to verify, yes. This flow events table, so target.flow events, is what the editor looks for when dealing with FlowGraph, and it's got 2 parts. It's got input and output. Input are all events that can be taken by this object, and essentially you just give them a name and you give them a function to call. So in our case, we're eventually going to go ahead and write a flow_lowered or flow_raised function so that we can just name it whatever we want. So raise equals. Then it's expecting 2 things in this order for the flow inputs. First is the function that you want to call back, so target.flowRaise. And the second is its type. In our case, we're just going to be using Boolean, so it's just going to say, hey, you've been called. And we'll do the same for lower. And so what we're going to do in this case is just go into create 2 new functions. So it should be target.flow lower, or wait. We can write it this way. I believe it'll work with the colon syntax because it is on the target table, but just to be sure, I'm writing it this way. Because this is how they had it in their sample scripts. And so all we're going to do on the lower and raise functions is go into either the lowering or raising state. So self go to state lower. And those are our inputs. So we can come over here and reload our script. I'll go ahead and open it up.
Just give me a second.
Okay.
Slow there, is that good? Good.
Does anybody know if there's something going on in this room at 5?
Not that I know of.
Okay. I don't remember seeing anything on the events calendar, but it's the copy. Okay, there is. So we might go a little bit over, but we are almost done with this. So is everyone done with that, or need more time?
No worries about going up, we'll just throw you into a flame pit.
All right, so if you go into View, open View pane and select FlowGraph. It will bring up the FlowGraph editor, and you do need to be in your level to do it. Now, unlike Kismet, it does require you to start a new one. It doesn't automatically start one for you, so you can just file new to start one up, and it'll create the save one. And you do want to save it. Save. And so I usually create a folder in here called FlowGraphs, and just save mine in here. And now, what we want to do in order to add this particular entity in is you select it in the overworld or in the editor view, and you just right-click, add selected entity.
What did you call your graph?
The default name is default. I just went with that.
Oh, okay.
Is it saying that for anybody else?
What was saying what?
Down here, entity target doesn't exist, or node for entity target, whenever you try to add selected entity.
I haven't tried to add selected entity. What are
Okay, in here, while you've got your entity selected, you right click and hit add selected entity. You should add a node for the entity.
Any target doesn't exist, no creation fail.
Okay, it's possible that it's because we don't have an output. So let me. Why is it not adding the node? Let me go ahead and restart CryEngine. While I'm doing that, I can get started on the outputs. The outputs are really easy in this case. For it, you just create a variable for whatever output you want, and then in quotes you put the variable type, so it can be a bool, int, vec3, entity ID, whatever you want. So for our raised, we're going to use a bool. Same for lowered. And then we don't have to add in outputs for these, but I went ahead and did it anyways for raising, lowering. And then what we'll do for our on hit is we'll create an output called hit, and we'll make it an integer value so that we can pass the score to FlowGraph. There we go. Okay, so it looks like for some reason it doesn't reload the FlowGraph events whenever you do a reload script.
How'd you get so those properties are public?
Do what?
The target, the properties raised, lower, all that, it's not showing that to me.
Do you have it as outputs, plural, or?
Output.
Okay, it does need to be both the inputs and outputs. Needs to be plural.
That would be right. Thank you.
Mhm. And now one thing to note about these is these are not automatically called. You have to call and basically say, hey, this event has fired. Go ahead and use it manually. And the way that we do this is we use a function on self called broadcast event. So if we go to we want these two, or all of these four, to fire whenever we have entered those corresponding states. So if we go to our onBegin state functions, then we can come into, for example, the raised. It should be, let me make sure it is a self broadcast event. Okay, it is actually broadcast event self, and then just a string representation of that. So in this case, for the raised, it would be raised. And this is what you use whenever you're broadcasting for a Boolean. This is basically for a broadcast event. You're not passing any value. It's actually just saying, hey, this has been called. We're actually going to use something different for our hit, which will pass along the value, which is our score. So broadcast event self-raising. Let's get the case doesn't matter. And low.
Lowered is broadcast event lowered.
Yes. All of these, it's just a string.
Okay,
Whoops, I messed that up.
That's the reason I asked.
Yeah. Just a string matching the output name here. So raised is raised and so on. And now for hit, we have to treat specially. And it is the activate output. So the first argument is the actual name here, which is hit. The second is the argument, which has to be the same type here. So if we come up to our server.onHit down here, or up here, after we've calculated our score, we can broadcast that, hey, we've finished that. And this one is on self, so self activate output. And we're naming it hit and passing score out. And so that basically concludes our Lua scripting portion of this. Everything else we're going to implement in the FlowGraph system. So we can go into the editor and reload the scripts. And then off of this, we're going to branch out and we want to do two things. We want to display a message to the user. And then once the box has finished lowering, after a certain amount of time, we want to go ahead and raise it back up again. So the first thing that we'll implement is having it raise back up again. Does anybody need more time, or?
I'm having errors.
Okay.
Sender no value. That's line 66. So it's 105 stuff.
How those lines were. Okay, so oh, that's her. No, it's, oh, you forgot self in the functions.
Oh, okay.
They need to
Yeah.
have self.
Thank you.
I messed that up the first time I was going through it. So you do want to make sure that all of your functions in the game states or in the entity states does have self as an argument. All right, better. Okay, so in the FlowGraph editor, once you've reloaded your scripts, we can go ahead and start working on making this lower and raise back up after it's lowered. So we can't directly link ourselves to ourselves, so lower to raise isn't working. So we'll go ahead and add a timer, and then after that timer expires, we'll have it raise again. So we can right-click over here, and it's got a very large variety of default nodes available, including many logical ones. And in our case, we're going to set a timer, so we go down to timer, and that will add that node, and you can just left-click and drag it around however you want. If you want to minimize it, you can click that little arrow up there. And just like in Kismet, the way that we do this, and you can right-click on the background to drag and move if you need to. So you just drag from the output to, in this case, reset, which will set this. The timer is not reset by default. It will be turned off until something calls reset. And we'll set the period, which is a tick period in seconds. So we'll have the target wait for 2 seconds before it goes back. And then out from there, we'll go to the raise function. So it gets lowered, or into the lowered state, resets the timer, waits 2 seconds, and then calls raise. So if you save your FlowGraph and go back into your game, by the way, it is much easier to work with CryEngine with multiple monitors. That is one thing I've definitely learned. So if you go into the game, shoot it, it lowers. Oh, I see. Wait, did I drag off of lowering or lowers? Lowered. Let me see here.
That's working fine for me.
It's working fine for you, you said? Is anyone else having the same problem? Broadcasting out, lowering, raising, lowered, raised.
what's weird for me is every once in a while when I shoot, the player's angle sort of changes. I don't know why that's happening, but.
The player's angle?
Yeah.
It might be the recoil from the gun. I don't know. Why is it? It's constantly switching between raising and raised. Still doing that. Where's is anyone else having the same problem I am, or is everyone else fine?
Mine's running just fine.
Okay, then I'm not going to worry too much about it on my end. The next thing that we want to add for this, and this will be pretty much the last bit that we add to this project for this workshop, in the FlowGraph, is whenever we're hit, we want to display a message to the user. Now, unfortunately, the scale form GUI that I was trying to work on for this was giving me a lot of problems because I did have something nice and fancy worked up in Flash for it. But we do have a function on the default HUD that you see whenever you load in to display a message to the user. And the way that you access any UI functionality like that is through a node again. So right-click and add node. Then all of the UI actions, events, functions, whatever, that have been defined for whatever GUIs you have in the engine will be under UI, and then you can go to functions. In our case, we're going to be using HUD 3D, so it'll be UI, functions, HUD 3D, then we're going to go ahead and use display message. And we can set the message to whatever we like, but one nice thing is the way that the outputs, if we're using some sort of value, if it matters, works as you send it both to the calling and to the actual message or whatever input it is. So here it's putting the output in message and using call. So if we save this and go into our game, then when we shoot, we should get a message saying, hey, this is your score. There you scored a 5, you've got a 4, 3, and a 1.
Where's the message display?
It's kind of hard to see on this,
Oh, I see it.
especially against the white of the
Okay.
board. So that's how you get it to display. Now that message will stay up until you call hide message. So what I had ended up doing was, when I was testing this out, I went through lowered,
No, that,
and I actually, if you go into UI functions HUD 3D again, there's also a hide message. So once it was lowered, so drag lowered to call, and on call to reset. Once it was lowered, I had it reset that and then go back. And so if I save this, and come in here, once that hits the lowered state, which in my case it isn't because my script is messing up.
So you're calling hide message from lowered.
Which is then in turn calling the timer and then raising it.
Oh, okay. So that's how do we delete the connection?
If you see the little dot on the arrow,
Yeah.
if you right click on it, you can disable, delay, or remove it.
All right.
That's one alternative to using the timer, by the way. Delete that. Deleting a node can be a pain because you have to click it and then right click and go to delete. But so if we go to it automatically inserts a time delay. So it actually seems to have been my timer perhaps that was causing issues, which is interesting. Except now I don't seem to be going to the lowering, lowered, raising, raised. Okay. So that's essentially how you set that up and how you go about setting up the scripts for it. And so you can play around with this as much as you like, going through just shooting the target and bringing it back up. FlowGraph does have a lot of nodes predefined, and then you can also script your own custom nodes that aren't related to the entities. Under game, scripts, flow nodes, you can just add extra flow nodes in there. So we can open this up, and that's essentially what it looks like for adding custom flow nodes. But the real power behind this scripting system is shown whenever you are making C++ edits to it. Adding the script finds is a really powerful tool, and it is something that I do want to do a future workshop on. The code for CryEngine is just very clean, very well laid out, so it's not hard. Like, for example, when you're trying to work with UDK, you have this absolutely massive entangled hierarchy list. CryEngine is a little bit cleaner about it as far as I've seen, and it's fairly obvious where most things are located for it. And so, does anybody have any questions?
Yeah, if I want to modify the speed by which the target falls inside the editor itself, which view should I use to do that?
It will be, that's from the property that we set, the end move speed.
Roll-up bar? Okay.
Mm-hmm. So if you go into, once you've got the object selected, you've got all the properties here. The entity properties, this contains everything that you've defined in this properties menu. Here's the one that I did for this. And once again, this comment here, if you ended up putting it in as well, is going to give a guide for that information. So for example, it should give me the tooltip, but it doesn't look like it's doing it. But if I use that to raise or lower, it's not going above 20 or going down 1 or below 1 and so on. So I can set it to 20 there, and it just drops.
Okay, what's weird about mine is when I shoot it, it looks like the value it's getting for its rotation is almost random. And so when it raises it up, sometimes it lowers just fine, but it sort of pops into, sometimes it pops like all the way down. And it's as though the information inside the, that I get for the...
Can you go to the lowering?
Yeah, that's what I'm doing.
Oh, the issue here is, if you notice, it's shooting multiple shots because the default gun that they give you is a machine gun.
Yeah.
You didn't have, like I put in a check here, I can pull it up, to determine if it was in the raised state. So what's happening is it's getting that multiple times. So on hit right here.
Oh. No, I put that on there.
Or oh, never mind. I was thinking incorrectly because you're on the lowering.
Yeah.
When you scroll down the line, lowering on timer. Okay, so it gets the angles. It gets its current angles. Speed times degrees to radians. It's probably because of that.
That should be just pi divided by 2. That should be the same number you're using up there.
Hmm.
It seems it's almost as though this value gets just almost random. It's not what my current angles are. It's, oh wait a second. you have this.
Oh, yeah. So I'm not sure what get angles would have been called on in that situation.
Good question. On the timer, maybe? No, actually, it wouldn't be. It couldn't be the timer. would it?
I have absolutely no idea what it could be calling on.
That's one thing I don't like about it.
The difference
The
between...
difference between
Yeah.
those two is really muddy.
That's why I've started messing around with Squirrel a lot for languages that I embed into my applications. You don't have to reload your script for
Yeah.
it. And if you just go right in the game, it'll automatically reset it.
Well,
Yeah.
there we go.
Except now it's giving the same problem that I was having.
Well, no, that's because it's, you have this, oh, that's interesting.
I think this timer may be interfering with the timer in the script, which what I just did for that is I went ahead and deleted that. Then on call to raise, then there was if you right click delay, it'll automatically add a time delay in here, which I guess is a little better. I hadn't seen that before when I was doing it. And so now it should delays it and then raises.
Cool. Fun, alright.
Does anybody else have any questions or comments about this? All right, then I guess that's it.
Oh, I did have a question. Where's the video going to be posted? Because
I have no idea. I'll ask Aaron afterwards.
All right. I'm expecting
Find out
a lot
where
of people are going to want to watch the video, pause.
Now, one thing is, if you go onto the CryDev website, this is kind of their layout of it. And like I said, Doc 5 is mostly related to scripting, while Doc 4 is more related to the C++ aspects. But even if you're only focusing on the Lua scripting, if you have no plans on ever touching the C++, that is still a good area to, because that's where I found out about toLocal. So if you come in here and you start looking at, for example, CryCommon, this has a bunch of your systems for it. It explains a bunch of information on your, excuse me, on your updates. So this right here, I mean, this is a lot of C++ documentation, or not C++, the Lua documentation for it, which honestly, this is a little bit better than the one in the scripting documentation area. So CryDev's documentation is very thin, unfortunately. It's nowhere near as good as Unity's documentation is. But going through and looking through the source code and looking through some of the C++ areas on their documentation, you can find a lot of the functions that you're looking for example, for transforming to a local vector, or vector from a world vector. And one of the biggest problem that I've had with this, because I'm not an artist and I'm not used to how everything works in the different art tools, is that it's really weird trying to mess around with the exporter system. But I mean, the Lua engine in here, they have done a lot to optimize it, and it is set up in a very powerful way. So even if you can't implement something directly in Lua, going in with script binds is trivial, as long as you understand C++ well enough. So I guess that's everything.
Well, one question I did have.
Yes.
When we're using Unreal Engine 3 at Raven Software, we initially played around with Unreal Script a lot, and we ultimately decided that that was just a waste of time, and we ultimately ended up using Unreal Script mostly as a header file
Okay.
to expose C++ to the editor, and that's it. And the rest of the code we wrote in C++. Is it possible to write the entity in Lua system in a similar way to do most of your game code in C++ rather than Lua?
I believe so. You'd mostly be wrapping calls to C++ functions in these functions in here. Maybe because, like, for example, all of this right here, all of these functions that we've been calling on self, it's all stuff that was implemented in the entity class in the C++ engine. So expanding on that, or even creating new entity types that these become, is really fairly easy. Most of what I've done with the C++ side of the house, which is where I spent most of my time so far, has been on the script binds, but I've been using the global because I'm just trying to add lead motion support into it. But I can open up the solutions, game code only. Going into here and editing the entity types and so on is not very difficult, and it is described in some detail in here. And for the most part, I've just been working off of looking at what's already in place and kind of basing it on that. So once Visual Studio decides it wants to open today.
Yeah, because if I select CryEngine for GAM 205, that's actually one of the things I want to be teaching mostly is on the C++ side, but not so much the Lua side.
Okay.
I'd say Lua for something like GAM 215. And so I want to make sure that people are writing game code in C++ as opposed to, yet another script language.
For the C++ bits, everything you're going to want to do is in the CryEngine project, not the CryCommon, which is default, because this is all what gets compiled into the game DLL.
Okay.
And so if you come into here, what's it? Close. Now, what you were talking about with the with doing most of the gameplay scripting in here, if you come into here, the game rules setups, I believe all of the default game rules are implemented through, so it's got the whole game rules system. So it's kind of tied both between Lua and C++. I haven't looked too much at the game rules side. But this is right here is what I've spent most of my time working with. All of these game rules headers, the script binds here. And so essentially, these are all functions implemented in C++. And here, I can actually look for the entity ones. Game files, game SCP, script bind, actor. So this is all information on, all code for the actors themselves. Doesn't look like the entity information.
Looks like that was macros to actually set the.
Yeah.
That's it. There's headset angles one.
Yeah. Just gonna go through all of these. Unfortunately, I don't remember right off the top of my head which of these classes it pulls from.
Well, the actual script find stuff, I saw the set angles function defined there, so I'm
Oh,
assuming the entity class inherits from that.
yeah.
So, you'll probably hit F3 again, and it'll probably show you where it's defined, or I'd F12 on that one, yeah.
See actor, camera seats. Okay, so. So it looks like actor.h is just blank, but then it's filled out in
Yeah, it's a virtual class.
subclasses, so. And yeah, they are using matrices for rotations.
Okay, it's kind of what I figured.
I'm not sure how much, I know defining script binds and script globals is really easy to do through the C++ engine. I don't know how much expanding on the actors or building out the actors in C++ is. I was actually planning on starting to play around with a lot of that in the coming weeks.
Well, at least it looks like the Lua site's functional, unlike Unreal scripts. So, but yeah, what I'd probably be doing if I were to use this for Game 2.5 then would be to do things like having them create functions for doing a jump, and instead of coding that in Lua, have a function that is exposed to Lua, written in C++ to do all the jump logic. But it looks like they already have their own physics system fully implemented, so we can tie into that.
The one thing that I did forget to pull up that I did want to show you, in the sandbox editor, once it loads up, you can come up to game up here, and this is where you set the default equipment packs for AI sets and single player. So this is where you've got all of that coming from. So you can set all of that up, including ammunition properties for each and so on. Or for each type of ammunition, rather. As well as add-ons and so on. So it does have a lot in the way of, it's focusing kind of a little more on shooter games, at least as far as the editor is concerned. But it is very, from what I understand, has a lot in the way of what you can do through the C++ engine. I just haven't, unfortunately, messed around with entity scripting or entity programming in C++ yet.
Okay. I'll be playing with that pretty extensively next semester, so.
And anybody have any other questions, or? All right.
Thank you.